we have a project where we've got a client who's ordered a custom threshold from us, and this video is to discuss and document basically the process of creating this custom threshold. Let's do that now. So what we're going to start with is attempting to import a vector into vCarve, and I've done it before. It works. It's just a simple functionality. Okay, so let's save this. Okay, so I believe that all I need to do at this point is to obviously double check everything. I won't record me doing all of that. I'm going to then create a proof of concept video and send it to the client. I'm then going to make a prototype, and that's where we'll pick up next. Let's do it. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. It's a fairly large piece of material. However, yeah, this is going to be problematic, very problematic. What we need to do is to do the profile cut at the very beginning. It needs to be the first cut. And when we flip the workpiece over, we're going to have to be nuts on the money. 9 passes, 1/16 of an inch. That makes sense. Outside to the right, separate last pass. I think we're okay. Well, actually, we're going to do the profile at the very end because it's going to be a lot of work flipping over a 4x8 sheet of 1/2 inch aluminum. That's no joke. We'll still be able to hold the workpiece down because it'll still be attached. So anyway, we'll see what happens. So we'll do a separate last pass at 20 thousandths. Start depth is 0, cut depth is 0.51. We'll see about that. 1/4 inch diameter, 9 passes, outside to the right. Last pass. We'll ramp into it like everything else. Final profile. Calculate. Yeah, we know that. Okay. Let's just do the top. But our final profile couldn't change our piece at all. We shouldn't see anything actually happen. Reset the preview, final profile. Yeah, we shouldn't see anything change. But to prove that it works, let's do 14, then 49. Then we'll see it work. V-bit top, got it. V-bit top. Let's flute the top. Now let's final profile. Yeah, that makes sense that you're actually seeing it trim. Okay, let's set our material back to 13 3/8 by 48.5. Okay, awesome. Okay, I think it's time to see if we can prototype this and see what happens. Okay, we've got the machine set up, and I believe it's time that we can actually try to cut this part. So let's actually try the V-groove on the top first. I've air cut it. It looks like it's fine. Let's give it a go.
not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, we've got the part flipped over, and I believe that we have our checks in a real good place. So we're going to run the V-bit profile at the bottom of the threshold now. V-bit bottom. Pick up the next bit, and we've got to zero it. So let's do a C1 8. Got to pick up bit number 8. Chris Burns pointed out it's a little bit scary. You can't see the tool change with this come down to 0 that bit. CN72, enter. Bit to 0 is going to be 8. We had to reset the control software, so I'm re-zeroing that bit. Yeah, we're going to do a CN, we're going to do a C2 after this as well. I believe we're going to want to do that. No, enter. Let's JH. Stop this video while I zero the bit to the material surface. Okay, we have the bit zeroed to the material surface for the bottom pocket. It's the 4th of 5 tool pass that we need to run, and let's run it. I did an air cut. It appears to be in really good shape. Some time to cut. Now we're at 16th of the sheet. So I'm going to watch it as it starts the second valve. Now we're 1/16 feet. Do a profile cut. At this point, would be an eighth of an inch deep, but then it's going to kind of get rastering the second head. And it's on the show file. So watch it start rastering. Okay, we'll pick it up when we are at the end of the last test.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, as you may recall, it's Monday and it was Saturday last that I was pocketing this. Well, we had a blowout, and what was happening was, first of all, the dust skirt was pushing down the material, and because it's, as I had showed you previously, we're missing part of it here, and this was the beginning of the fourth pass of the pocketing, and it pulled the workpiece up and just destroyed it over on this end. So, really good that wasn't a very expensive piece of aluminum. So I've got an idea about how to change the approach, and what that approach is going to be is I'm going to do the pocket first. I didn't do the pocket first because I wanted to have a lot of material down. I did not want to have a piece of material that wasn't even on the spoil board. But I realized, since I'm Z-zeroing off of the material surface because I want an accurate depth of cut, it doesn't matter what I have underneath it to build this piece off. So I'm going to do my pocket first this time. I'm going to do the V-bit down the bottom, then I'm going to pocket it. I'll be able to have the entire piece of MDF now securely fixtured down to the table so that there's no concern about it blowing out. The advantage is once I flip the workpiece over, I'm going to have, because of the tool path, I'm not going to be doing any perimeter cutting that will get in the way of any mechanical clamping that I do. This threshold does not have any holes for screws, otherwise that would be an obvious way to hold it down. So the tool pathing that I'm going to try now is V-bit first, pocket second, profile, flip it over, put it on top of a piece of spoil board that I don't care about, and I can clamp all of it down. So I'm going to go about doing all of that, and I'll check back in when we've got something to report. Thank you. Okay, so we've had a catastrophic failure. The MDF has been curling up, and the last pass just broke this all loose. So we're going to have to think about how this is going to get a lot smarter. Yeah, so I think the problem that I'm having is the material. It's MDF, so it's curling up at the back end, and I'm getting deeper cuts than I need to. And I think what I'll end up doing is offsetting the next piece, offsetting the tool pathing a couple of inches down on the X so that I can get mechanical hold down out here. I think that's going to be the key to this. Now the aluminum is going to be extremely rigid, so it's not going to curl up. That's for sure. But that's, I guess, why a prototype was so important, because I learned something about this. So we will pick this up next time.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.